In this video, I'm going to walk you through some of the homework problems that I think worth talking about, and I will try to emphasize the application of R and RStudio as well. And also, if you find anything that you don't understand or you think I have some mistake in this video, please feel free to let me know. Okay, the first two questions involve the basic concepts like sample size, observational unit, and variable. So I'll do one of them for demonstration purpose. So the first one asks for the variable, which is the width in this case, because variable is a feature or characteristic that we want to look for a certain subject. It is obviously a continuous variable because width is just like length, something we talked about in class, which is continuous, which is something that you can keep dividing them. And thirdly, the observational unit in this case is obviously specimens of extinct mammals. And lastly, the sample size is 36. This is actually an interesting one, and if you cannot remember or recall what this one is about, you can refer to page 33 in your textbook, in which you can find a detailed description about what's going on. There are two ways to do this problem. You can either do this by hand, which is pretty intuitive, but it involves a lot of work, obviously. The other way is do this by R. And in the following, I'm going to demonstrate how to solve this problem in R. Okay, at this moment, I assume all of you guys have access to the R software and RStudio. You are able to launch software and see this user interface. If you still cannot, just refer to my previous video and try to figure out how to do the installation. So the first thing you want to do is click this icon and make a new R script. The first thing you want to do is to input all the data, but before that, let's give it a name. Because this is from the schizophrenia example and MAO is the name of the enzyme level. And this is how to assign a vector of values. You have to put a C in front of this, in front of the string of numbers. So we start with 6.8, and they are separated by comma. And the second one is 8.4, separated by comma. And you keep doing this. Okay, now you can double check. You have separated all the observations with a comma. You might also notice that I have a space after the comma, but that is not mandatory. I'm just doing this to make my code more readable. So next thing you want to do is run this line of code. You can put the cursor here and hit command and return together. So you will see two changes here, first thing here, and you will see something here. What matters is this part, because the computer has learned this variable and it has stored the variable in its RAM, and you can use this vector later. So you have to do this before you move on. The next thing you want to do is to find the maximum and the minimum of this vector, because in order to divide all the data into different bins, we have to understand where our data is starting from and where our data is ending with. So the way to do this is pretty simple. Min for this vector, and hit command return, and you will get 4.1. And similarly, the maximum is 18.8. Okay, now we can find all the cutting points to define all the bins so that we can put the data into each of the bin. So in this case, we can define another vector. That's our cutting points. And I would like to start with something smaller than 4.1, probably 4, and something bigger than 18.8 so that we can cover everything. And of course, we want something in between. Probably, we can make the length of bin to be 3, let's say. So that gives us 7, 10, 13, 16, and 19. So that is all the cutting points. And don't forget to run this line of code. So you see the cutting points, they showed up here. And what we want to do next is we actually to count how many values between 4 and 7, between 7 and 10, between 10 and 13. Of course, we don't do this ourselves. We use a function that is called cut. And the data we have is MAO, and we want to cut the MAO data by the cutting points. And we want to organize them in the form of a table. So that is everything you want to type in. And if you run this line of code, here is what you'll see. This means there are 3 observations between 4 and 7, and so on and so forth. Okay, next we can plot a histogram based on the data. If you watch my previous videos, probably you will know this is basically what we can do. However, this is not what we want exactly, because in this case we have customized the cutting points, and the cutting points of this histogram is not consistent with ours. So how to fix that? Basically, we can specify an option which is breaks, and we can specify the cutting points that we just defined as breaks, and click return. See, we have 5 different classes, and these 5 different classes is consistent with what we have designed. Namely, they are from 4 to 7, 7 from 10, 10 from 13, and 13 to 16, and 16 to 19. Oh, by the way, if you feel this is a little overwhelming, don't get frustrated, because this is kind of like more advanced stuff. And I think the textbook just wants you to do something by hand. I'm just giving you guys a shortcut. You know, it's okay if you don't feel comfortable at this moment doing this. Basically, from 2.3.3 all the way up to 2.3.7, they are all about finding the mean and the median for a given data set. You can either do this by hand, of course, but you can do this in R as well. I'm going to show you how to do this in R. And of course, I'm only going to do one of them, the first one, 2.3.3. I have already typed in the data here. As you can see here, they are separated by comma, and there is a C in front of this vector, and give it a name, question 233. So the thing you want to do is type mean question 233. And don't forget to run this line first, so that computer knows that there is a vector called question 233. And then you run mean, and similarly you can get median, which is 6.3. For this one, I don't think there is some shortcut. Basically, you just want to recover the data from the table and then try to find the value in the middle. You know, for instance, you see there is 1 5, and there is no 6, and there are 2 7s, and there are 3 8s. So you keep doing this until you have recovered the whole data set, and then you find the value in the middle, and that is the median. Okay, the last 2 questions are about the box plot. And the rule that is really important, and you have to really memorize, is 1.5 IQR, which is a rule of thumb for you to detect any potential outliers. So let's see how to use this rule in a real question. So luckily, they are still talking about the MAO data, so you don't have to type them again. It's here, MAO. So the first thing you want to do is to find out the median and the quartiles. The median is kind of simple. You can just do median and MAO, and here you go, 9.2. But the quartile is a little trickier, and there is one shortcut that you can use. Is actually summary. It will give you that 5-number summary for any data set, so you don't have to specifically ask the first quartile or the third quartile or the median. Actually, it will give you that 5-number as a whole, so MAO. And as you can see here, the minimum, which is the first number of that 5-number summary, the first quartile, median, mean, third quartile, and maximum. You see there are 6 numbers in this case actually, because the mean is the extra one. So you can answer this question by saying the first quartile is actually 7.5 and third quartile is actually 11.6. So I think the interquartile range is kind of simple now, because it is given by the third quartile, which is 11.6. Copy paste this, minus the first quartile, 7.5. And it's called IQR. And let's print IQR. It's 4.1. Okay, next up, define outlier, or define the upper boundary of being an outlier, which means if there is now a suspect here, and you can compare that suspect with the boundary. So how to find the boundary? The third quartile plus 1.5 multiplied as this asterisk IQR. Here you go, 17.75. And this means if your potential suspect is greater than 17.75, then you are pretty sure that it is an outlier. At last, you are supposed to generate a box plot, and this is how to do it. Box plot and MAO the data, and just run this line of code. And here is the box plot. Well, you might wonder, I see a lot of horizontal box plot in the textbook. How do I do that? It's kind of simple. You can change the option here by typing horizontal equal to true, which is T, and it becomes a horizontal one.